Hello everyone. Today in this video, we are going to study about the 2-cube factorial design. Previously, we know how to calculate 2-square factorial design. If you have not seen the video, just visit our channel, just see 2-square factorial design and come back for this particular video, which tells you about the 2-cube factorial design. If you have not subscribed to my channel, kindly do it. We'll quickly move on to this video, how to calculate this 2-cube factorial design for the optimization of any product. Okay, so it is one of the optimization technique. So we are going to study about the 2-cube factorial design, which is the next thing for 2-square factorial design. After 2-square factorial design, we are going to study about this 2-cube factorial design. So what is it, where to use, how to use? We are going to just study about this 2-cube factorial design with an example here. Okay, so first of all, we would like to have an example just like 2-square factorial design. So imagine this boy, see, for example, is little fat, so he just wanted to become like this. Okay, see, for example, see, he just wanted to become like this. Okay, so he's given 3 treatments here. First one is a pill. Okay, so he has given a pill. Okay, then he has given a diet. Then he has given an advice on doing an exercise. So these 3 things I'll call it as factor A, factor B, factor C. So these 2 will be having see, for example, this I'll keep it as factor A, factor B, factor C. This example has been explained in 2-square factorial elaborately. You can visit and see. So now each one will have 2 levels here. Okay, diet, pill, placebo, I'll call it as levels. Okay, so now these 2 also will be having a level. These 2 also will be having a level. Now, I just wanted to find out the combinations here, whether this pill is responsible for this, and diet is responsible, or exercise is responsible, or A and B combined together will give you, B and C combined together will give you. So now A is a factor, B is a factor, C is a factor, and A, B, I'll call it as interaction factor. So which one will be most useful for this boy, this boy, to become like this? See, we just wanted to see. So this is the typical situation where we have a factorial design here. You know how to do this. See, same thing. So he has given 3 things. One is a pill. Okay, another one is the dietary regimen. Okay, regimen is nothing but a plan. Okay, we'll call it as a plan. And then is given a exercise regimen. That's the plan. So which is useful for him for the weight loss. Okay, so now this is the situation where I will use a factorial design. Okay, now all types of combination I want to find it out. So we are using 2-cube factorial design here. We are going to study about the effect of A, effect of B, effect of C. These are all the factors, and these are all the interactions between the factor, and this is the combined interaction between all the 3. This is what we are going to study. We'll quickly move on to what is called 2-cube factorial design here. Okay. So 2-cube factorial design will have 3 factors. Okay. So see, for example, A, B, C. Okay. So these are all 3 factors. Okay, 1 minute. Okay, now, so which is having 2 levels here. The levels may be low or high. See, the low level is given as minus, high level given as plus. Okay, sometimes they'll write it as -1 and +1 also. So both will be given here. So now the treatment combinations are given by like this. Okay, now A is, this is the low level, this is the high level. Okay, this is the high level, this is the low level, this is low, high, like this. Now, see, whenever we are having the low level at all for all the factors, that will be denoted by 1. Okay, so you have to remember. Now, when there is a positive sign, which is called the high, Okay, has been explained already in 2 square factorial. You can visit and see this, right? This is high level for factor A, therefore it is denoted by A. Now here high level is for B, therefore it is denoted by B. So you have to keep it in mind. Now here this is high, this is high. This is for the factor A and factor B. So therefore I am just denoting it by AB. Now go for C now. This is high, therefore it is for the factor C, therefore it is written as C. Similarly, when we go for A is high, C is high, so it is denoted by AC. This is the notation you have to keep it in mind while doing the factorial design here. Now A is high and C is high, so it is denoted by the letter AC. So now here B and C is high, so it is denoted by BC. Now when we go for this one, A is high, B is high, C is high, so it is denoted by ABC, just like that. Okay. So now when we write like this is called Yacht's notation. This has been explained already. Okay. Now, so how to give this as a graphical notation? Okay, this particular 3 factorial design, I want to give it as a graphical notation. How can I do it? Okay, so there will be a cube here. Okay, so you have to remember that will be a cube. Okay, so now this cube, you can see the corners here. Okay, so now I am denoting the 3 axes with the factors here. Now this is factor A. So now lowest level will be here. Okay, now 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, I'm giving. So this is called. Okay, now this is the surface you have to remember. Okay, now in the surface I am taking, this is the negative value, this is the positive value, here it is the low value, this is the high value. Whenever I say plus, it is the highest value. Similarly, this is the low value, this is the high value for factor B, this is the low value and high value. Now when I go for here, this is for factor A, okay, negative. For factor C also negative. Now go through this. This is the edge, right? This is the edge. Factor B is also negative. So this particular point will be denoted by 1 here. Because all are negative, you can see here. Okay. So 1. Where it is being noted, I am going to show it, right? So this will be shown here. You can see here. So negative, negative. Now A is positive and all the others is negative. A is positive here. So it is increased here. Now it is not moved here, so it is negative. This is also not moved here, therefore A will be positive. Just like that, you have to note down AB. For example, AB, right? A is positive because it has moved from here and then moved here. So A is positive, B is also moved here, factor. Okay, just like a movement you can remember. So therefore it is AB. Now you go for B now. Okay. You go for B. Now C, A is not moved at all. Okay, and this C is also not moved at all. Only B is moved, so B is positive alone. Okay, like this you can remember. Now go for AC. Now A is moved here and then C is moved here. B is not moved here. Okay, B is not moved here, therefore I'll call it as AC. Just like that you can remember this one. Okay, so now how to note it down in this. Okay, now sign table for treatment combination is given already. Now this is interaction here. Now A already we know B. Now how to do it for AB? Now so old mathematics you can remember. See, minus into minus will give you plus. Okay, like this AB. Then plus into minus will give you minus. Minus into plus minus. Plus into plus will give you plus. Minus into minus gives you plus. Okay, plus into minus minus, minus into plus minus, plus into plus is equal to plus. So that's over. Now when I go for C, is already from the table. Okay, this is from the table, this is from the table, this is from the table. Then I want to go for AC. So what is A here? Minus. What is C here? Minus. So minus into minus will give you plus here. Now here plus into minus gives minus. Okay, now here minus and minus which gives you plus. Just like that I'm going to include this. Similarly for BC. Now how to do for BC? Either you can take AB and C or you can take A and BC. That is your wish. Okay, so I'm going to take it from A and BC. Okay, so now A is positive, BC I'm sorry, A is negative, B is positive, minus into plus will give you minus. Similarly, plus into this is plus will give you plus. Like this, I'm going to fill up the column. Then we follow the same order, yards notation here. Now go for the treatments here. Now ABC, so it's here. Now A is positive, so it is denoted by A. All the others we can leave here. Okay, now only thing. So now you have to note it down. This is the sign table for the treatments here. So now we are moving on to how to calculate this, the estimate of the effect here. Okay, now estimate of the effect in a factorial design, the main effect of an independent variable is its overall effect averaged across all other independent variables. This we have done while doing the 2K factorial design in the previous video also. Okay, now effect of a factor A is the average of the runs where A is at the high. So A is at the high, I'll take the positive value. Level minus the average of the runs where A is at the lower level, so minus. So keep it in mind, wherever there is positive sign, you take the values here, A plus BC plus ABC, like that. Wherever minus is there, I'll take 1 plus 1 minus A minus B, like that. I'm going to average it. That's what I'm going to do here. I'm going to show this here now. So now, symbolically, effect or a factor, I will take all positive and then all negative. I'm going to subtract it. Okay. Now, this is nothing but the effect. So, because y bar is given, I'm going to take the average here. This short formula I can remember. If it is tough for you, you can remember. Take average of all positive, average of all negative, subtract them. Okay. So that's what is the thing you have to remember here for the effect factor. Okay. Now the equation rearranged like this. See, for example, A is positive here. AB is positive, AC is positive, ABC is positive. So I'm dividing by 4n, where n denotes the replicate. Whenever I have the replicate only, I should take n, otherwise I have to leave it. Okay. So now here 1 is also negative, B is also negative, C is also negative, BC is also negative. So it is previous sign table, you can check it out. So main effect of A. Similarly, I am going to do it for all the effects and finish it off. Okay. Now calculating the effect, I'm going to give an example here. Okay. So now I'm going to find out. So now for A, I'm going to calculate. Okay. Whichever I showed in the previous screen, I'm going to work it out. So now where is positive here? Okay. Now A is positive, so I will write A here. Okay. Now here positive, so I'll write AB. So plus AB I'll write. Then here it is positive, so I'll write AC plus AC. Okay. Now divide by 4n, so I'm going to give it as 4n. For the replicate, I'm going to write it. Okay. Commonly, I'll write for both. Then this should be subtracted with all the negative values here. See here, this is also ABC should be there. I left it here, ABC also. Okay. Now positive, so I'll take ABC. Finished. So now I'm going to do it for the negative value here. Okay. What is negative? Negative is here 1. So I'm going to write 1 here. Then I'm going to negative, it is B. Okay. So now minus B. Then negative, it is C. Okay. Minus C. Then negative, it is here BC. So I'm going to write it as BC. So 1 by 4n as usual, I'm going to write. Okay. So this is how I'll write. So once I finished it, so I'll get an equation like this. See, for example, I showed it as a effect. Now here A. Now what are all the positive value for A? Here, 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 here. So this corresponds to A. So it is over. Then AB, AB. Okay. Then here AC, here AC. Then positive ABC. I'll take it in one column and then minus values in other column. See, minus value, I'm going to show it here. So minus, so it is 1. So it is given. Then it is easy if you write like this in a tabular column and finished off. Okay. Now take the average of this, take the average of these two column and finished. Okay. So now how to do this here? This is the from column 1. Okay. So it is a rough work. You can have column 1, this from the column 2. This is how your effect of A will be calculated. Now, once this is calculated, I'm going to just show it in the, just like this, I'm going to show it. Okay. Now you see here. Now you have to imagine, just check it out. Where is this 1? 1 is here. Okay. Now where is B? B is here. Now C, where is C? C is here. Then BC. So now imagine this particular this particular side. Okay, this particular side will not move here, so it will be lower value. When it move here, this will be higher value. You can see clearly from the diagram here. Okay, now so now go for it now. Yeah, this is it. Okay, this is not moved. Now this is the value given here. 1 BC BC is the negative phase. I can say negative phase. Similarly, when I go for this is the positive phase. This is the highest value. So whenever my experiment has got an highest value, that will lie it here. Okay, now whenever it's a lower value, it lie it here. Okay, similarly, this is for factor A. Now just check the arrow mark here. It is moving like this, just like a cardboard you are having. It is moving in a place just like it. You can keep it in mind. Okay, now if it is not there, okay, so now when I go for this, okay, now this 1 and A and AB and B, this one will the lowest level for this factor C. This will be highest level for this factor C. Similarly, I can go for factor B, this particular thing. Okay, just like the phases, you can remember. This will be easy for you to remember the main effect. By calculating the side, you can do it. Otherwise, by calculating the value, just like the previous method, you can do. Whichever is easy for you, you can do it. Okay, this is the graphical method. Previous one is tabular column method. You can find out and finish it. Okay, now estimating the simple effect. See, it's already given in factorial 2 factorial. Just go through it. So this is what is the positive value, and negative value is the simple effect for factors. Yeah. Okay, now when we go for estimating the main effect, this is what is important. Main effect, just like the calculation we have to do previously, we have done the calculation. Main effect of A is given like this. So I have made it as a smaller one here. Either I can remember like this using a diagram, tabular column, or using the cube you can remember. Otherwise, the shortcut you can remember. This shortcut also you can remember. Now keep it in mind. A minus 1 means A minus within bracket 1. Okay, you have to remember this is the effect which we are going to have it. Okay, either you can remember like this in the short form, or in the short form you can remember. I'm going to show it for the main effect B. This short form is this one. Okay, this is the short form for this main effect of C, the short form. Okay, so now whichever is easy for you, you can remember. Either you can remember using a tabular column, either remember using the this is the cube one, or this the direct way of doing it, otherwise the shortcut. Okay, whichever you are comfortable, you can remember while you are calculating the main effect. Now similarly, the same thing is done for the interaction effect also. Interaction effect also I am going to show it in the short form. Okay, you can remember for AB minus comes, for C it will not come. Like that you can remember some way. You have to remember here to do this. Okay, this is the interaction factor. How to calculate? We have done it in 2 square factorial design also, the same thing. Only one factor is extra for this. Okay, after calculating all this interaction effect, we are going to do an ANOVA here. Okay, now here estimating the interaction effect is nothing but for ABC also. This is what is the formula we have to remember. Okay, so this is a shortcut for the formula. Now keep it in mind, whenever there is a n is nothing but number of replicate. Okay, now if I am doing only 1, then it should be 1 by 4 into 1. Okay, now first experiment also you take it as 1 replicate. Okay, replicate means similar type of the sum repeated. Okay, so we have to keep it in mind. N is equal to replicate. So statistical testing using ANOVA, the same way we are going to do it here. A is SSA, SSB I'm going to calculate, SSAB, C, AC, BC, BC, SSE. So here 8 is coming. So why 8 is coming here? See, it is the 2 replicate we are going to do for the example here. Okay, so now calculation of sum of square will be in the 2 cube design with n replicates. The sum of square for any effect is given by the formula. You can remember this. Okay, now contrast. So 2. What is that contrast? A plus AB plus ABC. Just like this, we have calculated 1 by 4, and now the same thing is called the contrast here. Okay, main effect calculation in the numerator, we can see it has the calculation without this 4n, that's called the contrast here. Okay, so now S is equal to contrast whole square divided by 8n, we have to remember. Okay, why this is coming as 8 here? because it is 2 cube, so it is 2 into 2 into 2, so I'm getting it as 8. Okay, that you have to remember. Okay, now the number calculated in the effect of any factors which is inside the bracket is called the contrast. That's what I told you. I'm going to show it in the formula here now. So now, which is the contrast here? Okay, now from here till here, this is the contrast. Okay, in a shortcut form, which is the contrast? This is the contrast. Okay, so you can remember. So this is called the contrast. The particular thing you will calculate, a number will come just like 80 for this, for example, and then I'm going to square it, 80 square. That's all is the contrast. Okay, so now these things are called, which is given in the red, is called the contrast. You have to keep it in mind whenever I'll calculate the main effect. This particular thing is called the contrast. So after this, I'm going to give you an example so that you will understand whatever we have discussed so far. We are going to give a simple example and we are going to finish it off. Okay, now imagine there is 2Q factorial design was to use to develop a model for preparing a nanoparticle of optimized size. So I'm going to get an optimized size, that is called the yield. Okay, that's called the variable I'm going to take it into consideration. That's called the yield. For this purpose, two concentration A and B. So I'm having A and B will be a liquid, for example, and C will be a solid, just like a powder. I'm going to use it. I'm going to mix it up to get a nanoparticle here. So which gives you the optimized size. I'm going to find it out. That's what is the smaller example I have taken. So what are all the factors here? A, B, and C. What is the minimum? What is the maximum? What is the minimum? What is the maximum? What is the minimum? What is the maximum? I'm going to take it. Those are called the levels. Okay, so that will be given as the level here. Okay, now I'm going to show it here. Now, once I do this, I will get the value as 550 as the nanoparticle, for example, nanoparticle size, for example. Okay, I have taken a dummy data. Okay, so if it is not matching the nanoparticle, kindly excuse me, because this is the value I have taken here for the clarity, right? So replicate, it has given the yield here. Now, so once this is being done, how to conduct this 2Q factorial? I'm going to show it here. Now here, factor A. Okay, so what is this minimum value here? It is nothing but 1 mg per ml. Now, what is the maximum? Maximum, this is 1 mg. Now, this is 2 mg. Okay, the maximum is 1 mg and minimum is 2 mg. Okay, yeah. Right. Now, for factor B, maximum is 0.8. Okay, so and minimum is, I'm going to show it in a different color. Yeah, so maximum is 1, minimum is 2. So for A, this is the minimum, it is 1, maximum is 2. For B, minimum is 0.8, maximum is 1.0. Okay, 1.0. So 1.0. Now for C, I'll go for the minimum is 30 mg and maximum is 60 mg. Okay, so now that's how I have done it. So I got two replicates here. I got a total. How to conduct a 2Q factorial we are going to see here now. So now I'm going to show it on the diagram here. Okay, so it is easy for me to calculate the main effect there. Okay, now I told you just like this. No, this phases you can take and calculate quickly what are all the interaction effects. Okay, so both. I can use a tabular column or I can use the diagram. So it is comfortable for me to use this particular diagram so that I have used it here. Okay, I have shown the values, total value here. I'm going to use it now. So what is my A value here? This much, B is this much, C is this much. I'm going to substitute in the formula for main effect of A. This is the formula for me. Okay, so now I have substituted. I have got the value as C. This is the value. Okay, it's a simple mathematical calculation. So main effect of A is given as like this. Similarly, I'm going to calculate for all the other values. I'm going to just move on. I'm not going to show it here. I'm going to move it on. Okay, here main effect of B is given the formula. Substitute the values here. Okay, so I got the answer as 7.375 for main effect of B. Similarly, I'm going to do it for factor C here. I'll quickly move on. So this is a simple mathematical calculation. So we can add and subtract here. 306 I'm getting. So for interaction, I'm getting for AB, this is the formula. So I'm going to substitute the value. See the values I have shown here. Okay, it is from the previous slide. You can work it out. Okay, you can work it out using a smaller calculator. It is easy for you, right? So once all the values are calculated, we will do an ANOVA here. See, this is how we'll calculate. Okay, right. So now main effect for ABC also is calculated in a similar way. So I've calculated 5.625. You can use software also, Excel also, you can use it for calculation. Otherwise, it is a normal calculation. Okay, just adding all this value and subtracting it, divide by 8. That's all. Okay, simple calculation. 45 divided by 8 will give you 5.625. So I have calculated for A, B, C, AB, AC, BC, and ABC. All the values I am just calculated. So I'm going to substitute for the ANOVA table here. Now the largest effect is for factor C, which has got 306. Okay, when I blindly simple effect I want to calculate it, I'll show like this. The largest effects for factor C is this one, factor A is this one, factor B it's not coming, so interaction effect is 153.625. okay, this is of no interest for us, so we are going to calculate for the total sum of square is nothing but SSA is nothing but, I told you, I gave the formula. I don't know whether you are remembering now or not. So any SS is nothing but contrast whole square divided by this particular value. Okay, so now 8 into 2 replicates, so it is 16. So contrast is nothing but 8 and 813 the whole square, which I have calculated for the effect A, main effect of A, whichever is in the bracket, that is 813 whole square. So once I calculate, I am going to tabulate these values here. Okay, so just like that. So if you want, I can show where from this 813 is coming. So here, see, here. So we'll do it for C, then you'll understand. See, I'm going to show it for the C. Okay, now this one. Okay, now here. So okay, so all these values here. Now interaction effects, only the thing which is in the bracket is this one. Okay, so leave this 8 and take this 24449. okay, now that's what we are going to use it here as the contrast. Okay, you have to remember what is a contrast. Okay, so to do it, okay, here 2449 is given. So once all these values are calculated, as usual, we are going to do an ANOVA table. If you do not know how to calculate the ANOVA table here, we have done 2 videos for ANOVA and 1 video for the 2 square factorial. There we have used and we have explained elaborately how to use this ANOVA table. So now I'm going to explain once again. See, the same thing is I'm going to just put it in a tabular column. Okay, so now I have done it in the tabular column here. Okay, now either I can calculate F calculated value. I'll call it as F critical also. F critical, then I can compare. Otherwise, I'll go for a P value here. Okay, I will go for a P value. Then I'll generate what is the thing is given here. Now, where it is significant, so it is shown here, and it is shown here, and it's shown here. Okay, now other things are not significant. So these are all the things which is significant, so that I can come to a conclusion and write it. Okay, now from the table we find factor A and factor C are highly significant. Finished. And the interaction AC is highly significant. That's what is shown here. Okay, now factor A significant, then factor C is significant, then factor E. The interaction AC is significant. That I'm going to show it again. From the table, we find that factor A and factor C are highly significant and the interaction AC is highly significant. Now, so I'm coming to a conclusion. There is a strong interaction between factor A and factor C because it shows here. Okay, this is how we will calculate the 2 cube factorial using ANOVA. Okay, so in the coming video to come, how to calculate this factorial design using regression, that's also we are going to study. Okay, so in the next video, okay, next video we are going to do this regression. Okay, how to do this particular factorial design using the regression here. Now we have finished ANOVA. See, just kindly go through what is called 2k factorial, 2 square factorial, 2 cube factorial design. So this is very easy and important also. So once you have done it, so it is easy for you to conduct an experiment to optimize any solution. Okay, so thank you very much for watching this video. If you like this, kindly subscribe to my channel. Thank you very much. Have a nice day.